And this is now a third way to do elimination through multiplication. What multiplication is going to allow us to do is we're going to manipulate an equation to make it easier for us to use addition to eliminate a variable. Shalom.
Okay, I know the first thing you do.
What do we do?
The first one is the one that we're going to change
And why do we pick the first one?
because it has an x by it, so
Okay.
it has only a coefficient.
Good.
And you're going to multiply the whole entire equation by both sides of the equation by 3.
By 3?
Positive 3.
So, by which 3?
Positive 3.
By positive 3. So if I turn this x into a positive 3,
Then it'll
and then
cancel
we
out.
add these together, are we going to get rid of a variable?
Oh, wait, what'd you say?
Wait.
If this is
Negative 3. By negative
by
3.
negative 3, good. Okay, so over to the side, we're going to do this multiplication. Negative 3 times x Okay, so we're going to multiply both sides by negative 3.
Negative 3x.
Now, on this side, what property am I having to use to deal with this coefficient? I'm using, John, distributive property. So I need to multiply every term inside of the parentheses by the negative 3.
Yes.
So it's negative 3 times x gives us negative 3x. Negative 3 times positive 7y gives us a negative 21y equals 12 times negative 3 gives us negative 36. So I take this equation, take the first equation, then I take our new equation that we have just used multiplication to modify it.
I have a question. How do you know when to add or subtract?
Well, in this case with multiplication, you get to choose.
Either way it'll work?
Either way, because, for example, we multiplied by negative 3, so when we add them together, we would get and cancel out the x term to 0. If we had multiplied just by 3, we still could have eliminated it if we had used subtraction. But it's easier to add than subtract when you're doing equations.
Okay.
Okay? So at this point, we're ready to add. So 3x plus negative 3x
0.
gives me 0.
So we're adding.
We're adding. So we're adding at this point. So negative 5y plus negative 2,
Does that say 21?
21y gives me what? Negative 26y. And negative 36 plus 10 gives me what? Negative 26. So I have negative 26y equals negative 26. What's my next step, TJ?
TJ. He said TJ. TJ, that's
We're right here.
You divide 26. Divide both sides.
We're going to divide both sides by
Negative 26.
negative 26.
That would be
Y is
positive
0.
y. And then it would be y equals 1.
So y equals 1. Now,
I have a question.
yes,
Will you ever come to a problem where you'll have to change both equations?
yes, and we can do that.
Yeah, because that's not what the homework.
Okay, we'll do both.
Yeah.
Okay.
Man.
So now, our third step of the process is the same regardless of the method we're using to solve the system of equations. So we take one of the equations, typically you take the easiest one.
Don't we do Y for the front end?
So we take one of the equations and replace y with the variable we just solved for. So this gives me x plus 7 times 1 equals 12. This is x plus 7 equals 12.
Man, I can't see.
We subtract 7. So we get x equals 12 minus 7 gives us 5. Now, we have to write our final answer as an ordered pair, x and y, so it's 5, comma 1.
So what all equations be like one-step equations?
All of these will not be one-step equations. No. Okay?
I love one-step
So,
equations.
at this point with this example, does anyone have an issue with any of the steps? Mr. Law? Everything.
You
Let's
only
look.
see y'all be failing them tests? Yeah, tests. Oh
Okay.
my God.
Let's look at the
You
example.
see my recent stuff in your
Mr. Law, where are you having a problem?
Okay, I understand when you do like 3 on both sides because you got one coefficient for the x. So, shut up, Tyra. So you might have 3 on both sides or something like that. But I don't get how you get
Over here? Okay. What we're doing, when we look at these two equations, we could use substitution. But substitution typically ends up being a lot of math to solve.
That's all.
So elimination is an easier method if we can use elimination.
I like them.
So when we look at these two equations, we have to think to ourselves, I need to get rid of one of the variables. Well, I see this x sitting here without a coefficient, which means I can multiply that equation by any number you choose. And then I can add it together, and we're trying to get rid of this
I
variable.
ain't gonna add it.
So if I'm going to add these two things together, and this is a positive 3x, then I need this to be a negative 3x. So when I add them together, it goes to 0.